Who's making something that's a beautiful sphere like that, that's 3 times harder than modern aluminum? If you can make something that's 3 times the hardness of modern aircraft aluminum, couldn't you draw better half moons?
Yeah, I should be able to.
Why does that look so shitty? How cool is that?
It's pretty cool. Looks like a helmet almost. And 12,000 years ago.
Greer's research team claims to have dated material from the Buga sphere to an astonishing 12,560 years old, a figure that, if accurate, could rewrite human history.
It's non-human technology. There is no question in my mind. This could change our future.
This object is a seamless metallic sphere captured zigzagging through the skies of rural Colombia in March 2025, now bears a laboratory timestamp suggesting it predates known human metallurgy by over 10,000.
It's certainly real. It's using an energy field, a type of anti-gravity effect.
In this video, we'll walk you through what these findings actually mean and why the implications stretch way beyond just archaeology. The discovery that shouldn't exist. March 2025 began like any other month in the rural outskirts of Buga, Colombia. The early morning light washed over undulating fields and scattered farmsteads, a quiet landscape punctuated only by the distant calls of birds. Farmers tended their crops, unaware that an event was unfolding that would ripple far beyond the borders of their region and challenge the foundations of human history. A metallic glint caught the eye of a laborer surveying a newly plowed field. At first, it seemed insignificant, a rock catching sunlight, an industrial relic buried by time. But as the man approached, the shape revealed itself, a perfect sphere, resting partly submerged in the clay-red earth. Its surface gleamed with a reflection that felt almost unnatural, smooth and flawless, free of scratches, dents, or markings that any conventional tool or machine could produce. The sphere appeared alien in its symmetry, yet undeniably real. The local community, accustomed to stories of strange sightings and odd occurrences, was immediately captivated. Some whispered that it was a hoax, a carefully placed object meant to draw attention. Others spoke in reverent tones, suggesting that the sphere was something more, a relic from another time, another civilization. Scientists were quickly summoned to examine the object, and as news of the discovery spread, curiosity shifted into global fascination. Video footage showed the sphere being lifted gently from the earth. Its metallic surface reflected sunlight in ways that seemed almost otherworldly, casting intricate patterns across the hands of those holding it. For many observers, the sphere's existence was mesmerizing, uncanny, and inexplicably compelling. The first scientific analyses revealed staggering details. The artifact, soon named the Buga sphere, was approximately the size of a bowling ball, weighing around 20 pounds, yet its construction defied every known principle of metallurgy. Its outer surface was a single seamless shell. There were no welds, no joints, no tool marks. The object had been crafted as though by a civilization possessing knowledge and skill far beyond any humans we currently know, or had ever known. Within the hollow core lay 9 to 18 microspheres, suspended and perfectly positioned in a precise geometric lattice. The spheres were flawless, uniform, and meticulously arranged, a configuration that immediately suggested deliberate design. Radiocarbon dating of organic residues trapped within micro-fissures on the sphere yielded a date of 12,560 years before present, situating the object in the late Pleistocene era. This time frame predated the construction of Göbekli Tepe by several millennia, predated the pyramids of Egypt, and predated the earliest known metallurgy by an astonishing span of time. For historians and archaeologists, these findings challenged the conventional understanding of technological evolution. If verified, the Buga sphere suggested a level of sophistication that should have been impossible for humans of that epoch. The object was not merely old, it was profoundly advanced, raising questions about what humans or other intelligences might have accomplished long before recorded history. Eyewitnesses who observed the sphere during its initial discovery offered descriptions that defied rational explanation. Several reported that the object seemed to hover slightly above the ground before settling, moving with a subtle, almost deliberate zigzag rather than following the straight path dictated by gravity. The sphere appeared to interact with its environment. Vegetation beneath and around it wilted, the soil became dehydrated, and grass that had been crushed or scorched refused to regrow. These phenomena were not merely cosmetic, they suggested an interaction between the object and the electromagnetic or gravitational properties of its surroundings. Soil samples collected from the landing site revealed anomalies that confirmed witness reports. Dielectric properties of clay changed dramatically compared to control samples taken mere meters away. Water content was depleted in ways consistent with rapid electromagnetic or energy extraction, a process modern science can measure yet cannot fully explain in natural terms. Organic compounds trapped in the soil exhibited unusual chemical signatures, further hinting at energy events that had altered the immediate environment. In other words, the Buga did not simply sit in the field, it left an imprint, a physical, measurable footprint that transcended normal impact damage. Early attempts to examine the sphere's outer surface revealed another layer of mystery. Using high-resolution microscopy, researchers noted subtle irregularities and patterns etched into the metal, almost like inscriptions or intentional markings. These were not scratches or abrasions caused by handling. They were precise, systematic, and too uniform to have been naturally formed. The discovery suggested that even the outer layer might encode information or serve a purpose beyond simple containment of the inner spheres. Some scientists speculated that the sphere might have been designed not only to survive for millennia, but to communicate through subtle geometrical and physical cues. News of the Buga sphere quickly spread beyond Colombia. International media outlets broadcast footage of the object, and online videos amassed millions of views. Scientists, historians, and enthusiasts debated its significance. Some dismissed it as a modern hoax, impossible to verify without in-depth material analysis. Others cautioned against jumping to conclusions, emphasizing the importance of methodical empirical testing. Yet even skeptics admitted the object's precision and construction were unlike anything known. It was a conundrum that demanded serious attention. Material scientists were soon engaged. Initial testing involved scanning electron microscopy, SEM, and energy dispersive spectroscopy, EDS, which revealed a metal composition primarily of titanium and aluminum, yet with trace elements such as scandium and vanadium in ratios that do not occur naturally on Earth. Isotopic analysis suggested deviations akin to those found in meteoritic samples, though the overall alloy structure was unlike any known terrestrial or extraterrestrial metal. Grain boundaries within the metal revealed thermal histories inconsistent with conventional forging, casting, or welding. In other words, the object's production method remained a complete mystery. Beyond composition, the internal microspheres suggested potential data storage or information encoding. Arranged in a lattice with precise geometric relationships, they formed patterns reminiscent of digital or quantum computing arrays, where spatial relationships dictate information. Researchers posited that the arrangement of the spheres might be a message, one that, if decoded, could reveal knowledge from an era lost to time. The possibility that a 12,560 years old object could contain deliberate encoding brought a mixture of awe and trepidation. Field scientists established protocols to preserve the artifact while analyzing it. Soil, air, and electromagnetic readings were meticulously logged. Passive sensors detected faint rhythmic pulses and thermal cycles within the sphere, hinting at residual activity or latent energy. The sphere, though seemingly inert, appeared to operate in cycles, a heartbeat preserved across millennia. Every observation reinforced the sense that the Buga was not simply a relic, it was a complex, functional artifact of a sophistication that modern humans could scarcely comprehend. The implications of the discovery extended beyond archaeology. If the Bugosphere represented knowledge or technology far beyond what we assume humans were capable of 12 millennia ago, it could redefine our understanding of civilization, engineering, and even physics. How did such an object come to exist? Was it the product of a lost human civilization whose achievements were erased by cataclysm? Or did it originate from an intelligence entirely separate from humanity? Every scenario challenged the boundaries of what was possible and forced scientists to expand their methods and imaginations alike. By the end of March 2025, the sphere had become an international focal point. Laboratories, universities, and independent researchers proposed experiments ranging from isotopic fingerprinting to electromagnetic and thermal monitoring. AI-assisted analysis was suggested to decode the internal lattice of microspheres. Every hypothesis, every test, was guided by the same principle: evidence over speculation. Despite viral media coverage and sensational claims, the consensus among professionals was that the sphere demanded a measured, empirical approach. The Bugosphere, resting under controlled conditions in Buga, Colombia, represented a paradox. It was undeniably real yet seemingly impossible. It was ancient yet technologically advanced. It left traces of energy and intent yet refused to reveal its secrets easily. Each discovery opened new questions rather than answers. And in that tension between what is known, what is suspected, and what remains hidden, the true significance of the sphere began to crystallize. It was a challenge to humanity's understanding, a test of our curiosity, and a mirror reflecting the limits of our knowledge. Even now, in controlled laboratories with sophisticated sensors and instruments, the Bugosphere emits only subtle hints of its inner complexity. Its presence commands attention, fascination, and respect. And as scientists continue to probe, map, and measure, one question remains at the heart of the mystery: who created it, and why? In the quiet fields of Buga, Colombia, beneath careful observation and scientific rigor, the sphere rests. But its story has only just begun. It stands as a reminder that history, technology, and human understanding are not as linear or as complete as we believe. Somewhere in the measured lattice of microspheres, in the flawless alloy, and in the residual pulses of energy, lies a message older than civilization itself. A message humanity may not yet be prepared to read. The architecture of mystery. The Bugosphere, now safely housed in a controlled laboratory in Buga, Colombia, revealed complexities that defied both expectation and imagination. Beyond the initial wonder of its flawless exterior lay a structure so intricate that every examination deepened the mystery. High-resolution X-ray computed tomography exposed the inner layers in unprecedented detail. 3 concentric metallic shells, each separated by narrow air gaps, encased a cluster of 9 to 18 microspheres. Each was perfectly spherical, each positioned at precise distances from its neighbors, forming a lattice of startling regularity. This was not random geometry. It was deliberate, designed, and encoded with an intelligence that human hands, as we understand them, could not replicate. Material scientists immediately focused on the metallurgy of the Bugosphere. The alloy, primarily titanium and aluminum, contained trace elements such as scandium and vanadium, but not in natural ratios. Isotopic analysis revealed anomalies suggestive of extraterrestrial patterns, though the overall lattice bore none of the irregularities typical of meteoritic matter. The microstructure of the metal defied traditional manufacturing logic. Grain boundaries displayed thermal histories inconsistent with forging, casting, or welding. No join lines existed between the 3 concentric layers. It seemed as though the sphere had been grown rather than assembled, yet there were no signs of additive manufacturing, chemical etching, or other contemporary processes. Every examination raised more questions than answers. Within the hollow core, the arrangement of microspheres hinted at functionality far beyond simple containment. Researchers observed repeating intervals, mirrored positions, and clusters aligned along axes suggestive of mathematical constants. Some spheres were positioned in ratios resembling the Fibonacci sequence, others in intervals consistent with prime numbers. Early computer simulations suggested that the spheres could encode information via spatial placement, essentially a three-dimensional memory device embedded in metal. The possibility that the sphere contained data from over 12,000 years ago blurred the line between artifact and archive. Pattern recognition became a central focus of the research. Teams proposed employing AI-trained neural networks to analyze the internal lattice. By scanning the positions of microspheres, algorithms could detect symmetry, clustering, and potential redundancy patterns, hallmarks of intentional design. Initial simulations revealed configurations unlikely to occur by chance. Each microsphere acted as a node, potentially capable of storing binary or even quantum information. The sphere, in effect, might be a cosmic hard drive, preserving data across millennia, waiting for the intellect capable of decoding it. Beyond information storage, the physical structure itself raised questions about energy and propulsion. The arrangement of spheres suggested nodes within a compact energy lattice. Some researchers hypothesized that if the internal geometry facilitated controlled energy flows, the Buga sphere could manipulate gravitational or electromagnetic fields. Such a network might explain the zigzagging motion observed during its descent. If true, the design represented a form of inertial manipulation, a method of propulsion that humanity has not yet achieved, but which could theoretically allow an object to move without engines or thrusters. Laboratory tests confirmed further anomalies. Passive electromagnetic monitoring detected faint, rhythmic pulses emanating from specific nodes within the sphere. These signals were subtle, far below the threshold of conventional detection, but consistent. Near-field mapping revealed clusters of higher intensity emissions, suggesting that the microspheres were not inert. Thermal monitoring over several days revealed cyclical heat fluctuations that did not correspond with ambient conditions. Nature does not operate in these rhythmic patterns. Machinery does. Even dormant, the object appeared to possess a heartbeat, a pattern of energy pulses that defied simple explanation. The implications for material science were profound. The ability to produce a seamless alloy with embedded microstructure and isotopic anomalies could revolutionize metallurgy. Grain boundaries suggested rapid cooling processes that prevented stress fractures, yet preserved structural integrity over millennia. No current laboratory could replicate such precision. The construction method remained hidden, yet its effects were measurable. A flawless external surface, resilient layers, and internal nodes perfectly aligned with geometrical rules. Some researchers turned to the possibility of encoded messaging. By mapping the microspheres as nodes in a graph-theoretical model, they began to hypothesize potential forms of communication. Repetition, symmetry, and ratios aligned with mathematical constants suggested not randomness, but deliberate signaling. Could the sphere convey information about its origin, or a message intended for those capable of interpretation? If so, the message was written not in words but in geometry and mathematics, the universal languages of structure and logic. The laboratory developed a multi-step verification protocol to explore these possibilities. Stage 1. Comprehensive material analysis, using SEM and EDS to document every element down to trace quantities. Stage 2. Isotopic fingerprinting to determine whether the metals could be of terrestrial or extraterrestrial origin. Stage 3. Microstructure examination to investigate the assembly method. Stage 4. Electromagnetic and thermal monitoring to detect residual activity. Stage 5. AI-assisted lattice mapping to attempt decoding of potential spatial information. Each step was designed to be measurable, reproducible, and transparent, offering a systematic pathway from speculation to evidence. This methodology also accounted for the integrity of the artifact. Non-destructive techniques, including optical microscopy, X-ray tomography, infrared spectroscopy, and ultrasound imaging, were prioritized to preserve the sphere. Only minute samples were removed for compositional testing, ensuring that the original artifact remained intact. The approach balanced the need for empirical data with the imperative of conservation, acknowledging that the object itself was both the subject and the repository of its secrets. Controversy accompanied the scientific inquiry. Media reports circulated claims that the sphere could respond to sound, that its weight fluctuated, or that fiber optic-like filaments inside connected the microspheres. While unverified, such stories reflected the fascination and fear the object inspired. Scientists maintained strict boundaries. Only observable, repeatable phenomena would guide conclusions. The sphere had entered the public imagination, yet the laboratory acted as the arbiter of truth, measuring what could be measured, recording what could be recorded. The deeper the analysis, the more the Buga sphere challenged assumptions. Its inner geometry hinted at intelligence beyond human capacity, its materials defied current science, and its internal activity suggested latent power. The sphere was more than a relic. It was a testament to design, precision, and possibly purpose. Each layer, each microsphere, each energy pulse spoke of intentionality, a quiet testament to a civilization or intelligence that remains hidden in the shadows of prehistory. At its core, the Bugosphere forced a reckoning with human history. Could such knowledge have existed before recorded civilization? If the sphere was of human origin, it suggested that ancient peoples were far more advanced than previously imagined. If the sphere was non-human, it implied contact or observation by an intelligence capable of crafting artifacts designed to survive thousands of years. Either scenario required humanity to expand its definitions of technological possibility, intelligence, and the very meaning of history. The sphere's existence also inspired reflection on time and legacy. An object designed to endure for over 12 millennia posed a question to all observers. How should intelligence communicate across the ages? Words decay, civilizations fall, and records are lost. Yet the Bugosphere endured, preserved with a precision that transcends human memory. In its geometry, its alloy, and its microspheres, it carried a message, a reminder that knowledge can be encoded in forms impervious to the passage of time. As researchers continued to scan, map, and analyze, the laboratory became a center of quiet anticipation. Every measurement offered the possibility of revelation. Every anomaly suggested a story waiting to be understood. The Bugosphere had moved from curiosity to challenge to enigma. It was no longer simply a sphere in the Earth. It was a question suspended in space and time, waiting for those capable of deciphering it. And so, in Buga, Colombia, the investigation deepened. The sphere rested, silent yet dynamic, holding secrets in its nested architecture, poised to transform our understanding of materials, mathematics, and perhaps even the origin of intelligence itself. It had arrived from nowhere, yet it carried everything: history, technology, and an invitation to probe the limits of human knowledge. Flight, energy, and signs of life. Beyond its flawless geometry and enigmatic composition, the Bugosphere revealed an even more compelling dimension: its interaction with the physical world. Witnesses at the initial site in Buga, Colombia recalled that the sphere did not simply fall from the sky. It descended in a subtle, zigzagging pattern as though guided by an unseen intelligence. A straight drop would be consistent with gravity, but this undulating trajectory suggested active stabilization, vector control, or inertial manipulation, concepts far beyond human engineering, even today. For scientists, these eyewitness accounts provided a clue that the sphere was not just a relic of advanced metallurgy, but potentially a device with functional systems, capable of manipulating forces that challenge conventional understanding. Field researchers revisited the landing site with precise instruments. Dead grass, scorched soil, and dehydrated clay were not mere artifacts of impact. Soil samples showed dramatic reductions in bound water content compared to control areas just meters away. Dielectric properties of the clay had shifted, a measurable alteration consistent with a massive localized energy discharge. These changes suggested that the sphere had emitted electromagnetic or electrogravitic energy, stripping moisture from the ground and potentially affecting the surrounding flora. This was not anecdotal. Laboratory spectroscopy confirmed unusual hydration profiles. nature could not replicate these effects spontaneously. Something had actively reshaped the environment. The concept of electrogravitics, controlling electromagnetic fields to influence gravity and matter, remained largely theoretical, but the evidence hinted at its application. If the Buga had indeed employed such mechanisms, the implications for energy and propulsion were staggering. Controlled flight without visible thrusters, the ability to manipulate local electromagnetic fields, and the preservation of delicate internal microspheres across thousands of years all suggested a mastery of energy that humanity has yet to achieve. To explore these possibilities, laboratories instituted thermal and electromagnetic monitoring. Passive sensors detected faint pulses at ultra-low frequencies emanating from the microspheres. These pulses were rhythmic, consistent with machinery rather than random environmental noise. Near-field mapping revealed concentrated areas of electromagnetic activity, potentially correlating with the lattice positions of the internal spheres. Thermal imaging over days revealed cyclical fluctuations unrelated to ambient temperature changes. Even in apparent dormancy, the Bugosphere seemed to operate on a schedule, a heartbeat encoded in energy patterns, a silent, persistent proof of function. Some scientists proposed that the internal microspheres acted as energy nodes, distributing, storing, or modulating power within the device. In this framework, the sphere itself was not merely inert metal. It was a compact, self-contained system capable of sophisticated energy manipulation. The zigzagging descent observed in Buga could therefore be a direct consequence of such a system. If the spheres functioned collectively, they might have allowed precise control over movement and stabilization, producing flight patterns that defied conventional mechanics. This was not mere speculation. Every energy signature measured, every thermal cycle observed, aligned with this hypothesis. Microscopic analysis of the outer shell provided further evidence. Certain areas exhibited subtle microerosion and surface topology consistent with controlled friction or energy interaction during flight. These marks were not uniform, suggesting directional exposure, leading edges experiencing different forces than trailing areas. High-resolution surface scans combined with AI-assisted simulation allowed researchers to reconstruct probable flight paths. The results aligned with eyewitness reports, a controlled, intelligent descent that left a measurable imprint on the surrounding environment. The combination of geometry, composition, and energy patterns suggested a level of design that transcended modern engineering. If verified, the Bugosphere represented an entirely new class of artifact, simultaneously a structural marvel, a data repository, and a functional energy system. It was more than a relic. It was a technological snapshot from a forgotten epoch, preserved with precision beyond the comprehension of contemporary science. Energy considerations extended beyond flight mechanics. The internal node's spatial arrangements implied the possibility of stored energy networks, capable of supporting autonomous activity for millennia. Thermal readings and electromagnetic monitoring hinted that the sphere might not be entirely inert. Some systems could still respond to environmental stimuli or potentially interact with measurement equipment. It was as if the object, silent for 12,000 years, retained the capacity for subtle activity, waiting for the right conditions or observer. Investigations also examined potential signals encoded in residual energy. Passive electromagnetic sweeps suggested structured emissions at regular intervals, while thermal cycles displayed rhythmic patterns over days. Such patterns, if intentional, implied a design anticipating measurement, a device engineered to communicate across time. Researchers began to theorize that the Bugosphere was both message and messenger, carrying its secret through millennia via geometry, energy, and matter. Further complicating analysis, the surrounding landscape itself acted as a record of the sphere's interaction with energy. Vegetation stress, soil mineral alterations, and localized electromagnetic shifts provided measurable evidence that could be cross-referenced with laboratory data. By combining field forensics with internal monitoring, scientists began constructing a model of the sphere not as a static artifact, but as a dynamic system, capable of altering its environment and responding to it. This elevated the Buga sphere from an archaeological curiosity to a phenomenon with tangible, reproducible effects. The implications for human understanding were staggering. If the bugosphere demonstrated functional energy manipulation and flight without combustion, it suggested the existence of propulsion systems previously thought impossible. Such technology could revolutionize aerospace engineering, energy storage, and even planetary exploration. Yet the sphere's age, over 12 millennia, posed a humbling question. If humans did not develop it, who or what did? Was it the product of a lost civilization whose knowledge was obliterated by time and catastrophe? Or was it an entirely non-human intelligence, capable of design, data preservation, and energy mastery across eons? Researchers also considered the sphere's role as a data archive. The internal microspheres, arranged in a precise lattice, could encode three-dimensional information in a manner analogous to magnetic storage or quantum systems. If energy networks supported the preservation of these microspheres, then the object was simultaneously a functional machine and a time capsule. Each node, each pulse, each fluctuation was a potential bit of ancient knowledge, encrypted in metal, geometry, and energy. Decoding it would require the synthesis of material science, computational modeling, and electromagnetic analysis, a challenge as profound as the object itself. In Buga, the sphere's presence continued to captivate. Local researchers maintained constant observation, while international teams collaborated via real-time data sharing. Every thermal shift, every pulse, every subtle electromagnetic signal was recorded and analyzed. The artifact had moved from curiosity to challenge to living enigma, a testament to design, intelligence, and endurance. It inspired both caution and wonder, prompting reflection on humanity's place in a universe where intelligence might persist in forms we scarcely recognize. And yet, despite the extensive monitoring, the bugosphere remained elusive in its communication. No readable signals emerged. No overt response was triggered by human intervention. Its energy pulses were subtle, its thermal cycles enigmatic. It seemed content to persist quietly, revealing only fragments of its capabilities. This restraint, deliberate or incidental, elevated the sphere from technological artifact to symbol of mystery, a bridge between human understanding and the unknown. At its core, the bugosphere's flight and energy patterns reframed how researchers approached the artifact. It was no longer enough to examine composition or geometry alone. The object demanded an integrated analysis, combining materials, energy, spatial arrangement, and environmental impact. Only by considering the full system, shell, microspheres, energy emissions, and field effects could its secrets begin to emerge. In this synthesis, the sphere revealed itself as a unified construct, a marvel of engineering, physics, and perhaps intentional communication, all preserved across 12 millennia. Thus, the bugosphere's story was no longer static. It had become a dynamic investigation, a scientific odyssey unfolding in real time. From the moment it was lifted from the Colombian soil, through its microscopic inspection, through the mapping of its internal lattice, and into the subtle monitoring of energy and thermal fluctuations, the sphere challenged assumptions, expanded the horizon of possibility, and inspired awe. It was a testament to endurance, to intelligence, and to the enduring mysteries that lie beneath the surface of history itself. The sphere, resting quietly in Buga, Colombia, carried within it not just information or energy, but a question that resonated across space and time. What is the measure of intelligence, and how does it leave its mark on the world? As scientists continued their investigations, every pulse and thermal shift was a reminder that the artifact was not merely a relic, it was a silent interlocutor, an enigmatic companion in humanity's quest for understanding. History, myth, and the open horizon. The bugosphere did not exist in isolation. Its discovery in Buga, Colombia, resonated with echoes of human history, myth, and legend. Across cultures, stories of lost civilizations, advanced technologies, and enigmatic artifacts have persisted for millennia. The sphere seemed to straddle that boundary between myth and reality, a tangible reminder that our understanding of the past is incomplete. If its radiocarbon-associated age of 12,560 years is correct, it predates known civilizations, pyramids, and even Göbekli Tepe, challenging the linear narrative of human technological evolution. Some researchers drew comparisons with myths of lost continents like Mu, said to have existed in the Pacific and harboring advanced civilizations. While science dismisses these accounts as legend, geological studies do confirm submerged ridges and microcontinents. Could the sphere be a relic of such a forgotten epoch? Perhaps it was a tool, a record, or even a message from beings, human or otherwise, capable of remarkable engineering before written history. Its presence forces reconsideration of what is possible, blending archaeology, mythology, and material science in an extraordinary intersection. Yet the Buga-sphere's greatest lesson may not lie in origin alone, but in the manner of investigation it demands. Open, methodical science, grounded in pattern recognition, isotopic analysis, energy monitoring, and AI-assisted decoding, has become the path forward. Each microsphere, each pulse, each thermal fluctuation is a clue to a story encoded not in words, but in geometry, energy, and matter. The object challenges researchers to decode intelligence itself, how it manifests, persists, and communicates across time. The sphere's silent endurance is a reflection of the broader human quest for knowledge. Civilizations rise and fall, monuments crumble, and records decay, but the Bugosphere, precise and unyielding, endures. It reminds us that information and design can transcend epochs, surviving not in libraries or inscriptions, but in physical form, preserved by precision, energy, and structure. For those who study it, the artifact is both a challenge and an inspiration, compelling humanity to expand its perception of what intelligence, technology, and history can encompass. As investigations continue in Colombia, the world watches. The Bugosphere represents more than an archaeological or scientific anomaly. It is a bridge between what we know and what we have yet to understand. Its mysteries speak of intelligence across time, the possibility of civilizations lost to memory, and the resilience of knowledge itself. Humanity stands at the edge of discovery, peering into a continuum of history that may be far older and more complex than previously imagined. The sphere, poised silently in its laboratory, invites a question that will guide inquiry for generations. What legacies of intelligence await rediscovery, and how will we recognize them when they appear?